Welcome to a lesson with Dr. Powell. Let's take a look at something on the unit circle that's kind of fun. All right, and we're going to come up with an inequality that's going to help us find a limit. Namely, we're going to investigate the limit of sine of theta over theta as theta goes to 0. This is a very nice limit. All right, so investigating it, let's think about this for a minute. Let's suppose this is theta, and if we're on the unit circle, theta is actually this length too, kind of handy, because in radians is just arc length on a unit circle. This is just happens to be 1. Now, let's look at something else here. What if we were to go right to the circle right here and draw a line that's tangent to the circle? Well, then that's a right angle if it's tangent. And the nice thing about it is this big triangle with the right angle there and this little triangle with the right angle here both share the angle theta, and they both have a right angle, which means that that angle is actually the same as that angle in the smaller triangle versus the bigger one. All kinds of nice things happen. For instance, let's think about taking the tangent of this angle. The tangent of this angle is sine, or which is the y over cosine, right? Sine over cosine. It's also equal to this length divided by 1, but they have to be the same. This divided by 1 has to be equal to sine over cosine, which is tangent. So thinking about this, whatever this is over 1 has to be equal to the same as the ratio of these, which is sine over cosine, which means that this guy is just simply tangent. Kind of fun to think about. The tangent part right here is just tangent. Okay, tangent here. All right, now what about this guy right here from here to here? What would that be? Let's think about what's also happened here. What we've done is kind of, if you think about ratios for a minute, think about this triangle, and these two triangles are similar to each other with the same angles. If you started with sine theta and cosine theta, and you have 1 here, then you divide everything by, so it looks like we got a 1 on one of the legs, and we got tangent. So it looks like we've divided everything by cosine. So that means this part is just tangent. This is just 1, and this part right here is secant. Hey, that's this part right here, the hypotenuse of the big triangle is just secant. Okay, so from here to here is a secant right there. Okay, so let's use this triangle that we see right here to kind of get a nice little feel for this limit right here. We're going to do some sandwiching. All right, so let's think about what this is. Okay, right here. Well, first of all, before we do sandwiching, we're gonna sandwich the idea of theta. Theta is an arc length, and so if we look at this, let's look at this picture a little bit more up close. If we round the corner, okay, and then we have that coming down, and we go straight down. The line over here is tangent. The line coming straight down is sine, and this arc length is theta. Notice how tangent is longer than theta, but sine is shorter. So we get a nice inequality. Theta is in between tangent, especially as theta gets small, right, to 0 here. In fact, for kicks, I mean, in our picture, we're just dealing with the right-hand limit for now, but it'll also work on the left hand. But let's just consider for now just the right, at least for our picture. So theta is in between tangent and sine. Very nice. Okay. So how can we use that inequality to get an equality for sine theta and theta? Well, we can do a couple things. All right. We could just take reciprocals of everything in this inequality. Now, think about the reciprocal function. 1 over x. That's a function of taking reciprocal. 1 over something is its reciprocal. This function is, in fact, even on both sides, is decreasing. That means that when you take a reciprocal, the order, if something is bigger over here, it's actually, the output's actually smaller. It reverses, when taking reciprocal, reverses inequalities. The same is true with anything that has a negative slope, such as negative x. Multiplying something by a negative has a negative slope, hence it reverses inequalities. So taking a reciprocal should reverse our inequality here. So we end up getting 1 over sine theta less than or equal to 1 over theta less than or equal to cotangent. All right. Now, since we're taking a limit on the right, then what would happen is sine theta is going to be positive. Okay, so let's multiply everything by sine theta. This whole inequality, and it's positive, so it'll keep the inequality going the same way. So this would end up being 1 less than or equal to sine theta over theta less than or equal to, well, let's see, cotangent is cosine over sine. So the sines, you multiply sine to it, it would cancel. So you're just left with cosine theta. Well, this is nice. You have a nice inequality for sine theta over theta. Because now as theta goes to 0 from the right side, let's see, this one goes to 1. And that, of course, goes to 1. So guess what this goes to? It goes to 1. So we have this nice limit. Limit as theta goes to 0 from the right side, sine theta over theta is simply just equal to 1. Kind of a nice, fun limit that we will be using a bit for various purposes as we move along. So the limit of sine theta over theta is equal to 1, and we get it here from there. Now, of course, this was the right-hand limit. Now, does it also work for the left-hand limit? Let's think about what happened for the left-hand limit. So for the left-hand limit, then we still get to this point just fine, especially since the inequality is, you still have that inequality reversal, even for negatives. However, let's just think about that for just a minute in the picture. Maybe we just need to kind of look at what happens in our picture when theta is, if we're looking at a negative theta, so going that way, negative theta and sine theta and tangent theta. Now, if theta is negative, actually tangent theta, even though it is this length, we do consider it as negative. Do consider that as negative, that is negative. So really we have the same thing to begin with that we had before, except all these are negatives, but the absolute values have that inequality. But because they're negatives, tangent theta is bigger in absolute values, so it's more negative. So we'd actually be reversed. Taking reciprocals will reverse the inequality again. So we have 1 over theta. And we have 1 over sine, and we have cotangent. Then we multiply by sine. Sine will be negative, which will actually reverse the inequality again. So we'll end up getting 1 less than or equal to sine theta over theta and cosine theta, but this is fine because we still have 1 and 1. And so this is still going to 1 even on both sides. So it really, this really works. We drew the picture for the right-hand limit, but it still works in either case. And we get that this limit right here is equal to 1 by sandwiching. Thanks for watching.